Okay, hello and welcome. I am Mike Mensch, Business Development Manager at Princeton Consultants. Thank you for joining us for today's webinar on optimization and AI precision agents. Please post your questions in the Q&A section at the bottom of your panel, and we'll address them at the close, which will be around 12:45. We will send the presentation afterward. Our speaker is my colleague, Dr. Patricia Randall, a director at Princeton Consultants, which she joined in 2007. Patricia leads the development and deployment of high-impact systems that help businesses optimize decision-making at the strategic, tactical, and operational levels. Patricia earned her PhD in industrial engineering from Clemson. And now, over to you, Patricia.
Awesome. Thank you, Mike. Thank you for everyone who's joined us today. I'm really excited about this topic and look forward to your questions at the end. So let's talk about first our motivation behind adopting precision agents as part of our optimization workflow at Princeton Consultants. Something that we've seen in many years of working with clients on optimization models and applications, simulations, operations research, MIPS, ML models, is that the questions that our users have are actually usually cross-domain. They don't fit neatly into any one bucket. But the tools that people build are often siloed. So you'll have models that solve very particular parts of the problem, but you've got to cobble together their answers for any question that you might have. So for instance, if a user says, what happens to my schedule if I reroute this shipment? There's a lot of different areas that can be impacted by that. So obviously you could resolve the scheduling model, but what does that do to your logistics, to your cost, to your capacity planning? Those are all different models, right? And so how do we answer questions and make optimal decisions across multiple domains or multiple business functions? Right now, a lot of people have static dashboards. Again, they're just showing you things and they're very siloed. They're not answering questions cross-domain. In fact, they're usually not answering questions at all. They're just serving up alerts or data. There are monolithic solvers, which we see a lot. Just optimization models out there doing a small piece of the problem. The scope is fixed. You built it to do something and it can do that one thing really well, but it can't flex into other spaces. And then now obviously we're seeing a lot of generic LLM agents, and obviously there's some really big players on the market. They can do everything from make your grocery list and help you meal plan to tell you all about your favorite movies or shows to writing emails for you, writing your resume, all kinds of things. But can they help you actually solve your business problems? Not really, because they're not trained on your business problems. They're just trained on this general knowledge base. So how do we address this problem? Um, we call this precision agents our pattern. And I think what's really important about this is we're not advocating for bigger models or models with a bigger scope. We're not saying that your model needs to contain every piece of your business problem. In fact, we're saying the opposite. There should be a lot of little pieces that come together. I think something that we see a lot in optimization in particular is that people want to keep adding to a model. They want to make this model all encompassing. It's the most globally optimum if you can bring in all the decisions. And that's true in a way. If you could bring in every decision and it was tractable and you could run it and you had the data and you knew all the questions, you could build, I guess, a really big model. But when I've seen this in real life, it's never works because it's got too much data, it's intractable, people have to make compromises to be able to solve at that scale. And so let's go in the opposite direction and trying to build a model that can do everything. Let's build an ecosystem of agents, and every agent will have their own task or tasks and will be very focused. And we'll group them, work with them together and aggregate them to solve these problems. So it's actually not bigger models, it's smaller models and smaller tasks that we then feed into a team of decision making. So what do we define as a precision agent? Very narrowly scoped, domain aware. So they all have a specific domain. They have a very tight focus. They're designed to support delegation under governance. This is really important. You're going to hear governance a lot today because as we get more and more into the AI landscape, we see the need for governance. They have specific models and tools that they can evoke, and they solve targeted problems. What they don't do is attempt to reason generically or to solve every problem. They all have a role. So think of it like a sports team. Most sports teams, people have positions, and every position does something in particular. And if you're in defense, you're not trying to score unless something crazy happens. If you're in offense, you are trying to score. You're not stopping people from scoring. And so these agents also have positions. They all do something very specific, but they're all coordinated under governance and orchestration. Like a team might be coordinated under a coach. They have explicit authority boundaries, which again, really important as part of governance is authority and the boundaries that we give these agents to make sure that they're operating how we want them to operate and not doing things that we don't want them to do. They produce auditable decision trails. Again, something that a lot of our clients are asking for is, we've always wanted to know, why did the model make that decision? This is way more important when it's on a deterministic myth, but now instead an agent who may not actually make the same decision twice, right? If you go into one of your favorite big LLMs right now and ask it a question and then open a fresh window and ask it again, you might get a very different result. Why did it do that? So we need to be able to audit and decide what trail did it go through to get to that result? Even though it may be different, at least we can understand how it got there. And they're coordinated through a governing orchestrator. So we use the term orchestrator to label our coach. This is the person who's keeping everybody in line, delegating tasks, bringing all the information back together to feed an answer to our user or to our system. What do they not do? Well, they're not actually replacement for optimization or simulation models. And I think in our community, the optimization space, a lot of people have been told or are worried that LLMs and agents are coming for optimization, that we'll just go to ChatGPT or Claude and they'll do all of our scheduling optimization or workforce planning or whatever. And they could do that. Like if you give a schedule, they could optimize it, I guess. But that's not really what they're for. And who knows what answer you'll get day to day. So they don't replace optimization or simulation and machine learning models. They use them. They are not necessarily requiring LLMs or full autonomy. Like I said, these are really narrowly scoped. They have a very specific boundary. These are not just ChatGPT or Claude or Gemini where you say, go and solve this, and it comes back having run all these calculations and come up with all these things and said, here you go. And you don't even understand how it got to that answer. And they don't attempt generic open-ended reasoning. We don't want agents to just go off the reservation, so to speak. And so we keep that really tightly reined in. Part of this is that we use what we call the solve framework. This is the 5 defining or qualifying properties of a precision agent. You can see that it's really about governance. We have stewardship, we have optimization, optimizing. So whether we're making a structured decision using optimization models, simulation, other tools, data products, there's always an objective and constraints encoded in that. Linguistic, obviously you've got to adapt the communication to match each target. Agents will be communicating with each other. They'll definitely be communicating with their orchestrator. The orchestrator will be communicating with other systems and with users. And so what is the linguistic properties around that? Precision agents are verifiable, and these are our real-time records for audibility, traceability. How do we get to that decision? It's not going to guarantee that we have the right decision, but we'll know why we got there. And so that can help us train these agents to get better decisions in the future. And then engaged. They're autonomous, but they're accountable and they're active participants in the decision-making process. So that's our solve framework. So all precision agents, whether what tools they're using, what domain they're solving, they will meet these 5 qualifying properties. Quick note about capability versus authority. So LLMs have a lot of capabilities right now, and it grows every day. And things that you didn't think a language model could do a month ago or 6 months ago, they can do really well now. And so we're going to see capabilities continue to increase. They could initiate payments and transactions. They can do that today. They could query accessible data sources. They could negotiate terms with counterparties. And we're actually working with clients where not as a first step, but as an eventual step, the agents are going to go in and they're actually going to maybe list things for sale or negotiate with vendors. And they can schedule and educate workflows or execute workflows. Now, just because they can do that, should they do it? What is it actually permitted to do versus what can it do? And this is really important. I was in a session last week on an on-site with a client, and they said, how do we make sure the agents don't go rogue, that they're not doing things that we don't want them to do? And one of the ways we do that is how we've scoped their authority. Okay. So we said they can initiate payments and transactions, but maybe only with certain vendors or only within certain limits. We can let them access data, but maybe they're scoped queries with privacy constraints, or they can only use certain data products to get that data. They can negotiate terms with counterparties, but again, what are those pre-authorized terms and the policies around that? And always we ask our agents to escalate when uncertainty or risk is high. This is becoming, well, hallucinations are becoming a little bit less of a problem with LLMs, but it's still an issue. And definitely uncertainty is an issue with any kind of language model. They can sound incredibly confident and then give you a different answer to the same question, also equally confident, completely different answer. They can give you very wrong answers very confidently. And when the risk is high, we've got to be really careful to escalate and say, okay, if you don't meet a certain threshold of confidence, not what you're displaying to me, but you've calculated, then we need to escalate that to a person to resolve. So that's really important to understand that just because an agent can do something doesn't mean that it will always be permitted or should be doing those things. This is a overview of our orchestration layer. Um, in this example, we're coming in from it from a user query, so maybe there's like a chat interface in the application. People are actually kind of getting back into chat interfaces, I think because they've become very used to interacting with chat through, the major LLMs. But obviously, there are a lot of applications and use cases, probably more not chat than chat. And so what we built out in our framework for precision agents and orchestration is you can obviously have user queries. They come in a chat, but you can also have batch jobs. You can have triggers, like you receive a piece of data that triggers a workflow, which will reach out to the orchestrator. You have all these systematic ways to tap the orchestrator on the shoulder and say, here, I have a request for you. So like I said, the orchestrator is our coach. They're the one who is looking at the precision agents. We've got a bunch of them. They all have various domains, and they know what each agent is capable of doing, what kind of questions they can answer or assist with, what kind of data they have access to. And so the orchestrator has a language model that helps it break down the question and figure out, okay, how do I parse this out into pieces? Very much like how a coach might have a game plan and figure out how each person on that team will individually contribute to that game plan. So it's sending those pieces to each agent. What's also nice about this orchestration layer is that you don't need to give the full context to every agent. Sometimes this context can be really big. Obviously, context is king and a big topic of conversation right now. Context windows are getting bigger and bigger. But do you want us in context, everybody? Context get floated? Is context rot? All that good stuff. And so if you can focus the context for each agent, that just helps them perform better. You don't want to give them more than they really need. That helps guide them to make better decisions. So the orchestrator will take the question or the request or whatever it has, and it will piece it out into the components. And might give some to an inventory agent, it might give a question or a piece to the compliance agent, one to the optimization agent. Then they go and they have their own toolbox. So everybody's got a toolbox. They are optimization models, machine learning models, simulations, data products, different tools that they can use via MCP. They might be APIs. You might be reaching out to external products via MCP as well as part of this. And so they have a toolbox of MCP tools that they can use as well to help with their questions. So they each take their piece of it. They call on their toolbox, figure out how to decompose their problem, figure out what they want to supply back to the orchestrator, and they all send back to the orchestrator their response. Then the orchestrator is in charge of checking, okay, what do I get from everybody? Does it match our policies? Do we have our auditability trail? Do we need to escalate anything from any of the agents? Do we feel confident about things? How do I piece this back together and package it up as a response? And that's the orchestrator's final result that they would pass back to whomever or whatever submitted them a request. So we have a quick example of this. RailChat, and I have a bigger example about RailChat in a minute, but this is a platform that we've developed for rail operations, and RailChat on this is the terminal operations side of it. So if you were in a rail terminal, like a transportation yard, you would obviously have lots of questions throughout the day that various agents could help you with, lots of optimization decisions and just operational decisions. And so, for instance, you might say, what's the operational status of track 3? And I'm concerned about safety, inventory, and the schedule. So the orchestrator said, okay, I get that. We've got a scheduling agent. We can ask that about the schedule. And that agent said, oh, well, the next departure is scheduled for 12:30 to city A. Okay. We've got a safety agent checking to see is it safe to use the track. In this case, the track has no safety permits that are active, so we can go ahead and proceed from a safety perspective with operations. And then we have an inventory agent who's saying, okay, what do I actually have on that track? And in this case, we have a locomotive and 8 freight cars, and they're all available. And so these agents each answered a very specific question. What's the schedule? What's the safety status? What's the inventory status? And then the orchestrator can bring them back together. Really important job that the orchestrator has is our policy precedence resolution. Sometimes these agents are not going to give responses that go well together, right? They conflict. And so when agents return conflicting responses, how do we handle that? That's the orchestrator's job once again, because they're the coach. When people want to do different things, they have to figure out how to make them work as a team. And so it consolidates all the answers. It has a policy precedence. In this case, this is in rail, this is a transportation yard. Safety is king, obviously. And so safety is always going to win. You can see that scheduling and inventory will defer to safety. In this case, all three were like, let's go, we're all clear. So it worked out. Um, but if they, in this next example, we'll see that maybe they don't all work out. And how do we handle that conflict? So for instance, are there safety risks for building the outbound train on track 4? Well, the safety agent said, well, yeah, because there's actually a safety permit on track 4 right now. It's not going to be clear until 2 o'clock. The inventory agent doesn't really care about safety. It said, no, we're good to go. It's empty, so we can use it to build. And my evidence is I have no freight or locomotives on the track. So the inventory agent actually would say, yeah, sure, you can use track 4 right now to build an outbound train. The maintenance agent is similar to the safety agent, but looking just at the maintenance side of it. And they said, okay, no, actually, there is a maintenance hold right now. And because they're working on signals, that goes along with the safety permit. And that hold is again until 2 o'clock. So you can see if we just looked at this inventory agent, it would look like we were all clear to use this track. But the safety agent and the maintenance agent said, oh, actually, we can't. We've got to defer. And so the orchestrator looked at that and said, okay, safety first. Everybody defers to safety. Safety agent says, nope, we're not good to go. You can see we've selected it. And we're going to say we're on hold until 2 o'clock to use this track. So typically, I think we'll often see conflicts between the agents just because they're all working on different parts of the problem. And that's why we need our orchestration layer to come back and make it all make sense as a solution to the client. How much of this we bubble up to the client depends upon the application. You can see this is a lot of detail, but perhaps if it's a user question, all they need to know is, yeah, there are safety risks right now because of the safety permit. They might not need to know the rest of this. We might just be keeping it in our audit logs so that we have that. But it's always there in the background, so if people have questions about it later, we can go back and take a look at what happened in that particular decision. So what are we auditing? What gets recorded? So every agent is built to have a decision trace of what they've done. We're looking at what is the agent, what was the query that they were responding to, what tool did they call? So in this case, this is the safety agent. This is the question from the previous slide. So it's talking about the safety perspective of the operational status of track 3. What are the inputs? There was an active permits database as a data product, also the track 3 configuration, also looking at maybe OSHA compliance, safety rules, escalate to a human if necessary. No hazards were detected on this one, so that wasn't required, but you can see how we would escalate it if needed. What was the decision, the confidence, and what was the policy that was applied? And so we're putting this in the background. We're auditing this in a log. Somebody asked me the other day, how long do you keep these logs? I think as long as we need to. This is pretty important stuff, obviously, although it's obviously very chatty. But you can see how you could have a record of all the decisions being made by the agents. This is important, particularly in the beginning, as you're starting to implement a system like this. People are going to have questions about why decisions were being made, and it's helpful to be able to reconstruct that decision path. Users are going to want to know. I mean, we always get questions from users anyway about optimization models and why they made the decisions they made. Now that we're bringing agents into the mix and they have tools like cross domains, we're going to get even more questions, and we're going to be able to answer that. So it's not just a black box to them. It obviously helps the developers as they debug and improve their agent behavior. And then regulatory is a huge aspect of this now. So when we were just doing optimization models like scheduling MIP, you didn't necessarily get a lot of regulatory people involved or compliance as long as you didn't have like, sensitive data, PII, that kind of thing. But I've definitely seen from our clients doing those same models, but now connecting them with AI and with LLMs. A lot of people want to get involved in that discussion around safety, compliance. How are you using the models? What kind of decisions are the models making? Can they make decisions without users? How do you have visibility into that? And so we're getting a lot of questions about that that maybe we didn't get before. And this is helpful in those discussions as well. And helpful just to say we have this history, right? This audit trail that we can always rely on. Because I think that going forward, people are going to need to be able to go back and figure out why these decisions were made when users are not so deeply in the seat of making that decision. Something that's really important when we talk about our agents is defining their boundaries. And so, what you don't want to do is make agents that are too big and that basically act like a ChatGPT or a Gemini or a Claude and they just do everything. That's not the purpose of these agents. The purpose is actually to make them as small as you can and as focused as you can. And then that allows you to train them on very specific responsibilities and tasks. So, how do we decide how to scope them? I like to think of it as almost the way that your business makes decisions, right? So, what are the business domains or business functions, and how do people operate in them? And then, how can we have agents in that same like set of areas? This is not necessarily how the tech stack is organized. I wouldn't look at the tech architecture and these tools and necessarily say, okay, this is how we should break things up. Instead, look at your business and think of it as a cracking pattern. How can we break this up into different business domains? And that makes a better agent pattern than, okay, we've got a database here and we've got a model here, because then we're still having those silo issues. Sometimes we need to bring those tools together. We want to think about authority and obviously least privilege and resource bounds. This is just like we have with people, right? In your company, you don't give people more authority or permissions or privileges than they actually need. That's just a safety and security principle. Same with agents. You don't need to give agents tools that they will never use. You don't need to give them access to things that they don't need. There's no need to have right access to databases most of the time, right? They're just reading from things like that. When must it escalate is really important to define as well for these agents. And then always exposing our models and data products and other things as tools, not as direct calls. So this gives them a little bit of an interface with the tools. It helps them understand how to use the tools because it's defined in the interface. What are the inputs and what are the outputs? There are contracts around that. MCP is really good for that. So we're wrapping everything right now, even API calls and MCPs, which is a little bit of a layer, but it just provides that authority and accountability and boundary, right? Of here's what you can use, here's how you use them, here are the things that you need to send it, and here's what you're going to get back. And it provides a little bit of structure around using the tools. So we've been using MCP. It's been working really well. I think it's kind of the leading tool wrapper right now. But we always say hold the technology lightly around AI. Things are changing very quickly. But that's what we're using at the moment. I think it's just really important to have some kind of framework around it and not have agents just calling models or calling database queries directly, but having a structure within it. And that also helps with the decision tree auditing because you can be capturing all of that in the logs as well. So when did they hit a tool? What were they sending the tool? What came back from the tool? All of those things help really well to create a good audit trace. The nice thing also about exposing models as tools is that they are black boxes to the agents. They don't have to know what is actually happening in that model or if it's a model at all, right? It's just a tool. They don't know if it's a data product, if it's an optimization model, if it's a simulation. It shows here's something that I can use to get an answer, and here's how I call it, and here's what I expect to get back. And so it's a good way to give an agent a variety of options and outputs and inputs that it can use without it needing to learn the details of each of them, right? It doesn't need to know this is a Garobi MIP model and here's how I call it, and this is an immunologic simulation and here's how I run it, or this is the database and here's the schema. It doesn't care. It just knows how to use the tools. And so again, we're really liking this as a design pattern for how we provide tools to these agents to use. Because the agents themselves are not going to be able to just answer the questions like an LLM, right? It doesn't have access to the data. It doesn't have necessarily the optimization ability or the simulation ability. The whole idea is giving a model, like a MIP model, a bit of like a user who's not a person sitting in front of it to help them use these tools and use these models. But it's not to replace models, obviously, which is LLM thinking and decision making and token following, right? It's to actually just put somebody else in the driver's seat of how we use these models and how we compile answers. In terms of multi-agent coordination, so we've got sequential routing. A lot of times we have ability to compose the requests into steps. The orchestrator is handling this, and they also, as we said, handle what happens when the agents disagree. So compose the query into steps, feed it out to the different agents. They all fan out in parallel. They give back results asynchronously. And then, as we talked about, the conflict resolution here is really important. So when they have competing recommendations, using our policy precedent to determine the outcome. And sometimes the orchestrator is going to have to decide that, and sometimes it's very clear. I think it's really easy if there's ever a safety agent, that one typically wins if they're in conflict, but there may be times when it's a little bit more nuanced over which agent will win, and how to handle that policy. That might be something you have to train the orchestrator on, or you also might need to escalate it if the confidence is below the threshold level. And that again is something that the orchestrator is handling. So we have two examples of applications that we have using our precision agent framework. I just want to give you an idea of the kind of agents that we have and the kind of questions that they're answering. The first, like I said, is RailChat, which is an operational intelligence tool for railroads. We've done a lot of work on the terminal side, and we're also building out the network operations side. And so when you think about a transportation terminal, there's a lot of questions and data and decisions to be made at all times. You've got all these tracks, you've got trains arriving, you're building out trains, departing trains, how are you classifying things, how are you doing your switching? So a lot of systems, when I've been out to these terminals, I've seen yard masters with many different applications open, many different screens. You've got obviously your terminal ops, all your alerts and your real-time data. You've got wheel data, train schedules, crew, obviously locomotive data, what's in mechanical, what's available, safety reports. But really, even for those railroads that have a really nice terminal operating system, there's still a lot of windows or a lot of things to bring together. A lot of questions that need different pieces of information to answer. And so you can't just rely on static dashboards to help with that. I mean, you can show alerts and there can be these red metrics and things are like, alert, alert. That doesn't tell you actually how to fix it or why it's happening. It just tells you what is happening at best. It might not even tell you what's happening. It might just be like, hey, you should check this out. But it definitely isn't showing root cause. It's not showing you dependencies, and it's not suggesting corrective actions to any of these. So with the precision agent approach, we've got AI grounded in the operational context. So it understands railroading. It understands terminal operations. It understands tracks and locos and blocks and switching and classification and all these things that are very specific to this yard and what the yard layout looks like, right? How are the tracks laid out and that kind of thing. It is signal driven, not blank prompts. So typically in our application, and I'll show a screenshot of this in a couple slides, we are doing a dashboard and we are showing alerts, and then those drive context. I mean, you could ask prompts, but the idea of blank prompts is that you see something and then the AI helps you investigate from there. And then when, like I said, we've got the yard chat and the network chat. We're talking more about the yard side of it with this particular example, but the network side, I think, has a lot of opportunities as well because the network side is very complicated. Like if you think it's complicated managing a yard, then you think about the whole network. A lot of decisions to be made, a lot of dependencies that maybe can hard put together. So in our RailChat agent architecture, we've got a bunch of precision agents. We've got train ops agent, inventory agent, hazmat, scheduling, build planning, and then kind of a general cross-domain one. The build planning is one of my favorite agents because it's actually doing an optimization model. So it's using a model that we built to optimize a train build using marshaling and the train schedule and car priority and all those good things that you think about when you're building a train. And so they're actually calling, different systems, getting different data, but they're also calling actual optimization models as part of this. For instance, if we saw that we had some outbound trains that are delayed, so we've got 3 trains, the average delay is 4.2 hours, the yard occupancy is 87%, is kind of high. Those are some signals that we have. How do we dive into them a little bit more? We could ask the train ops agent, we could ask the inventory agent, the hazmat agent, different ways to get information from them. And then you can see we could add the bill planning agent. It could actually help build a track for us, maybe moving some cars or helping us resequence. And so we're able to reach out to these different agents, and they all provide a piece of that answer that comes back to the user. Okay, what do we do about these outbound train delays? We are seeing that the tracks are at capacity. How do we get rid of that? Well, we can send some cars to storage, for instance, and help clear some capacity. So these are the kind of things that might be driven from a dashboard, but then using agents to actually find a resolution to them. And then this is an example of what it looks like. As you can see, a bit of a dashboard. And we've got a chat going where, I'm talking about different things. Like today, I said, I like to build train 123. And it said, great, okay, well, the next departure is scheduled for track 3 at 12:30. And then the build planning agent actually ran the optimization model and said, okay, I have 2 build plans for you for train 123. And I'm going to recommend this one that has the least blocks out of order, 0 out of order, and only 1 track switch. That actually sounds like a pretty good train. And so that's an example of using it in kind of a chat mode. Like I said, we've also got batch and trigger mode and other things, but this is intended to be a very interactive tool in which people are seeing different alerts and then trying to dive into those alerts a little bit more and then figuring out how to resolve them. So what did we learn, particularly from RailChat? First, that AI must be grounded in operational context. So again, this isn't a generic chatbot. It's actually using language models with your operational metrics, your domain rules, your structured data to be decision support, not just chat. Users are starting from signals, so they see these different metrics and different pieces of information. And if you click on it, that can actually launch an investigation into it. So again, they're saying, okay, something is weird here. How do I resolve it? Or how can I find out more information? Why is this happening? Because dashboards and AI are actually stronger together than either one of them is alone. AI doesn't do anything without data or context. Dashboards can provide context, but dashboards can't provide root cause and resolution. And so together they create an issue or workflow of see the issue, ask about it, drill deeper. This is helpful because users want explanations, not just answers. I mean, this is very common, right? Like again, in optimization space, users are always wanting to know why, not just what. And so AI can help explain that better than just seeing the results of an optimization model or maybe a data query. But we also saw as we were developing this that chat needs structure, right, for operational work. Again, this is not the same kind of maybe workflow that you see in your day-to-day life where you're just chatting with a model and asking it like, help me meal plan and figure out what to eat today or, whatever. This is very focused on operational things. You might be investigating emotional issues at a time, so you might have threaded conversations. It's not just kind of a stream of constant chat. You might be going back to things. And so when we're introducing a chatbot for work, it needs to be a little different than just what you see maybe in your favorite LLM. So that was the RailChat case study. This was the first one that we did with precision agents. And you can see it's very user focused and very chat focused. But our next example is a airport retail analytics platform. And this is actually less chat focused and more trigger and batch focused. So it's kind of a different use case for it, but still you'll see the precision agents at work here. This platform is all around optimizing what they call non-aeronautical revenue at airports. So this is basically trying to get you guys to buy more when you're in an airport. And so I apologize in advance if this works out and gets you to pay a little bit more. Airports are kind of like malls, really, because you're at an airport and you just see all these stores. You might have a little bit of time, but the stores don't change that often. They have pretty generic offerings. They have fixed layouts. You don't see the stores switching around, right? You actually don't really even see them changing their inventory that much, maybe a little bit of seasonality. But how many times have you been in a Hudson in an airport? You know exactly what you're going to get there. And really, there's actually not a lot of data-driven adaptation in airports. There's a lot of cool technology in airports, and we're learning more and more about things like occupancy tracking and that kind of thing, but we're not seeing it in the retail space. And part of that is the disconnect because the airport has different data than the airlines have, than security has, and then the retailers have. They all have their own piece of information. There's not a lot of data sharing between them. So these are even more siloed than we even see in operations because these are actually completely different entities all operating in the same place, in the same square footage. So like TSA knows exactly who's coming through security because they've scanned your boarding pass. The retailers don't get that information. The airlines know exactly who's on a flight coming in or going out. The airport doesn't get that information generally. And so everybody's got kind of a piece of the puzzle, but we've got to bring all the data together to help make better decisions around how to optimize these revenue opportunities. Uh, Something that we're seeing with the precision agent approach is trying to use the space smarter. So like I said, there's not a lot of opportunity to move stores around, but there are opportunities for pop-ups and for discounts and signage. A lot of the signage in airports is digital now, so you can change it pretty easily. So we're looking at not so much how to use the space better, but how to entice people to spend more time in the spaces, and then that will hopefully lead to more revenue for everybody. What we've also learned, which is interesting, is that airports will often share this revenue with retailers, and so, but they're also like min spends and that kind of thing, and so this is something that benefits both airports and also the retailers in them. We've got agents that are predicting things like passenger volume and dwell time, which are really important because the more people you have and the more time they spend in the airport and then presumably around stores, hopefully the more they'll spend. They're recommending product mixes. Again, depending upon what type of flights you see, you might have different needs. Passengers who are going on an international flight actually don't buy a lot of food because international flights often have meals on them, sometimes multiple meals. And so you don't see people, getting like McDonald's before getting on the plane. The domestic flights obviously don't serve meals for the most part. Sometimes they don't even serve you drinks anymore. And so you'll see people buying more food and snacks that have domestic flights or shorter flights, right? And so even understanding just what kind of flights operate out of a terminal near that retailer will really make a big difference. And really talking about conversing with teams in their own natural language. Our client calls this prose engineering, not prompt engineering, and it's getting down to where you don't have to, for a long time, people were a long time being a couple of years because AI hasn't been around that long in this context, but you had to be a prompt engineer, right? You've got to ask the correct prompt. And now we're getting more into context engineering, but really people want to ask in prose. They want to ask in their natural language. And how do you train the agents to be able to handle that? So in this case, you can see we've got our same general architecture, but what's different are the precision agents and what tools and data sources they have. So now instead of having safety and mechanical and train building, we have passenger flow and dwell time and sales performance and retail opportunity, pop-up planner, digital signage. So we have a bunch of different agents. They all do very different things than what we saw before, but they do it in the same architecture, in the same framework. And so, for instance, we could say, where should we put up a pop-up next week? And then we would go and say, okay, how do we break that down amongst these agents and what tools are they calling? There's, obviously the FIDS and AODB flight data. We've built a cognitive twin to simulate people in the terminals and how they're moving about and how long they're dwelling in certain places. We've got point of sale transaction feeds. That's really important to see how much actually has been sold and what people are buying. Some airports have passenger flow sensors that we can tap into. And then there's a lot of forecasting, obviously, in this particular platform as we're trying to figure out who's going to be here and what are they going to be interested in buying. So for instance, we could say if there's vacant retail space near gates E12 to E16, what should we put there? And you could see if we look at where peak volume is and what that volume looks like. Maybe we have some ideas of what would be good retail opportunities. For instance, we have a lot of volume in the morning. That would be a good place for a pop-up coffee shop concept. So those are the kind of questions that we can answer looking at who's going to be there and what are they going to spend and what do we think would be the best use of the space. Or, for instance, we might say maybe it's not a pop-up, but maybe they just do a special on certain days because we see a lot of traffic that would really benefit and maybe be open to buying if there was maybe a sell that we could encourage. And then again, just to screenshot, this is an example of, this is the platform And you can see this is a major international airport in the US, and all their retailers. And this is the dashboard looking at the heat map of where people are and where we expect them to dwell. What did we learn from the airport retail analytics platform? Um, Modular data onboarding is really important for this use case. So in the case of RailChat, this is a terminal's data, a railroad's data. They have all this data. It might be in different systems, but they have it. But in the retail analytics platform, it is not all just the airport's data. Some of it is, say, the retailer's data or the airline's data. And not every airport is at the same level of data maturity. And so what we had to do as we designed this application is we had to figure out how to modularize it to say, okay, if you can only bring this piece of data and this piece of data, what can we provide in terms of output and decision making versus if you bring all the things that we asked for? And so trying to find a way to ramp up people who maybe are a little bit less mature in data capture and maybe don't have the POS data or maybe don't have the people tracking data, so they still get value out of the application with maybe a more limited data set. Conversational AI can really change the user relationship. As we again said, we're talking about prose engineering, not prompt engineering. So that's something we're really thinking about. Really important, again, that this is not a monolithic model. We have a bunch of different agents. They're all doing different things. And then something that is a little bit different about this platform is we build a cognitive twin, and that actually lets the user do various what if scenarios to figure out what if they did add a pop-up or just the store hours. And an agent is actually running that simulation. What do we think would be the results of that? Some generalizations across both of these are the agent boundaries can follow operational responsibilities. This helps to decide how to scope them. Again, not based on where your data lives, but what are your operational decision making. Provenance is non-negotiable, and provenance just means what's our decision trace, right? Like, how did they get here? To us, it's a day one non-negotiable that we need to figure out. We need to know every decision that the agents made and why they made it and what tools they used and what they sent to the tools and what the tools sent back. And so that's something that we've designed and built in from day one. Orchestration is really the hardest part. That orchestrator sits at the top. They actually don't have a whole bunch of tools, but they actually have a very hard job because they're dealing with intent interpretation, trying to figure out if we have chat questions, what these questions mean and how to decompose them, how to handle the multi-agent routing, the conflict resolution, which is super important, and then the response assembly. This is all really the key. Like the precision agents are important. They obviously provide pieces of the puzzle. The orchestrator is the one who puts the puzzle together and has the final picture to deliver back to the requester. And then matching the model size to the agent scope. Do you always need an LLM? Maybe not. There are small language models, there are open weight models, and they can be just as good as LLMs in these cases because, again, they're just really focused problems. None of our agents are expected to do all of the variety of things that a commercial LLM is expected to do. They have a very focused scope. And so you can have a smaller model that's well trained. Open weight lets you train it yourself and get the same or actually better performance because you're not dealing with these big agents who have this ton of stuff that it might be drawing from. Some pitfalls that we've seen in this, overscoping agents. Obviously, you really don't want them to do more than they absolutely need to do. So keep it simple. They should only do as much as they need and not any further. And if you find that they have a lot of tools or a lot of things that they're doing, maybe that's a good way to break up that agent a little bit. That might be a sign your agent is overscoped. Under investing in the linguistic property, particularly if you are using chat, which people are getting very used to, it's different, particularly as an optimization modeler, to think about conversational interfaces versus what we typically see as a model interface where maybe there's a run button that you hit and you just get results in like a spreadsheet or, a Gantt chart or something. Treating auditing as an afterthought, much harder to build in if you haven't tackled it from the very beginning in your design. And again, it's very important to us, and it'll be very important to your compliance and security officers and to your users and even to your developers. And then objective misspecification. So agents can optimize the wrong thing very precisely. And so something that we want to always be tracking is what are they doing? What decisions have they made? Are we seeing drift in them? Continuing to test them to make sure they're making the right thing. They're optimizing for the right choices. because they can drift easily if you're not watching them. And then next thing you know, they're answering something very specifically, but it's not the question that you actually were looking into. And then finally, when is this the right fit? So we're not going to say that precision agents should replace every single application out there, every single piece of your organization's decision making. But we think that when the decisions are consequential, when you want auditability, when the trade-offs are real, multiple objectives, no single correct answer, which we see a lot in optimization. You want authority bounded and enforced at runtime. You want to coordinate multiple models and data sources. Or priority shift and governance must adapt because, if you just have a model and you want to change the objective, you got to go and encode the objective. Maybe there are ways that have the agent help with that. These are all good times to use agents. But if you have workflows that are really fixed, they're deterministic, maybe the stakes are low, maybe you're not worried about auditing, or it's just content generation, you don't really need to delegate multiple agents. Maybe you don't need precision agents. I'm definitely not going to argue that everything should have a precision agent wrapped around it, or every optimization model needs to be part of this precision agent ecosystem. Sometimes they don't. Just from what we've seen, many operational business problems really would benefit from this because they do have these complexities. So a quick recap, and then we'll get to questions. Like I said, narrowly scoped, that actually orchestrate, not replace your optimization models. They can coordinate multiple optimization models. The conversational interface really changes how we think about design as an optimization or analytics professional. And this is a reusable pattern that you can adapt across industries. As you've seen, we've got two examples that are very different. We're working on a third right now for a client that is, again, in aerospace, but a very different business case than the retail analytics. And what we're saying is the same framework adapts because the agents and their tools are what changes, not the framework. And something for all the people out there who are optimization people like me, we're not replacing optimization models with language models. We are giving those models users that can help them so that people can use them and bring them together and do cross-model orchestration in their business decisions. But I will never say that we can replace all of our MIPS and simulations and machine learning models with an LLM. And that's not what we're trying to do with this. So to all those who are like, I've heard ChatGPT is going to replace everybody's jobs, it might not replace all of these optimization models. So that is all that I had. I wanted to say thank you, and I'll open it up if we have any questions.
All right, thanks, Patricia. Yes, so we've enabled the Q&A. So at the bottom, feel free. We do have time. I'll start. I'll echo a question that you got when you gave this presentation at the Informs Analytics Plus conference a month ago. Someone in the audience, which was, by the way, really enjoyed, they really enjoyed your talk, asked, could you please tell us what is the difference between an agent and a tool?
Yeah, that's a great question. And when I was asked this in the presentation, I was like, wow, what a great question. So the agent is the decision maker. They're kind of acting like a user. It's a proxy. They're making decisions. They're gathering data. They're doing things with it. The tools are the analytical capabilities that they're using. So the tools might be an optimization model. It might be a simulation, a machine learning model, data product. A lot of tools are actually just access to data as part of that. But the tools themselves don't make decisions. They just provide input into the decisions, which then the agent is the one who's in charge of making it.
Got it. Okay, we've got another question.
Okay.
Patricia, how are you training these precision agents? Is there a reinforcement learning aspect to the orchestration design, or is it more a case of refining the context prompt through trial and error, or something else?
Yeah, that's a great question. And it is understanding what are all the questions or the use cases that you'll have and training the orchestrator how to break them down. So not necessarily reinforcement learning, more, and also like you have RAG, obviously you might need to send it some context with that. So it's more understanding when I get these questions, how do I have to break it down to solve them and saying, so it's a lot of question training and saying, okay, I need to do this, or I want to answer this, versus trying to train it to do many, many things. So it might need some context, but really the orchestrator is actually pretty light. But it has to understand who can answer what and how you parse your questions, which are very domain specific, into agents, and also what those agents do. And so the biggest part about the orchestrator is that you do have to train it per domain. You can't rely on the orchestrator being able to handle all the domains together because they need to understand what each agent brings to the party, basically. And so you can teach it how to decompose your requests into pieces and what pieces can be answered by each agent.
Got it. Okay, we have another question.
Mhm.
How do you run tests of your precision agent system? Ultimately, the business would like to replace humans with agents, but how to make sure they are comfortable with these AI systems?
Yeah, and I wouldn't advocate for that, but I also don't advocate for replacing people with optimization models. So what we have this concept, we've got a couple different names for it. I like to call it the weight room. If you're gonna go pump up, do some training. Steve Sachar, is our CEO, calls it the agent dojo, where you go and learn how to be an agent. And what it is, it's a framework that's actually monitoring agents. And so obviously you have agents that have been running for a while. People are very worried about drift. We have a client who's very worried about collusion between agents. And so you're kind of running them in a shadow mode and seeing how they're responding to things, and you're watching the questions and the answers. You can feed it like a steady state, kind of a test harness. And it's like a souped up test harness, honestly. And it's always keeping an eye on what are the agents doing and what the confidence looks like. Do we need to retrain? Is it answering things well or not? And it's just gathering a lot of metrics around that so that you can find out, okay, am I doing a good job with this? Am I providing good answers? I would also love to capture from the users if they liked the answers or not, but that can be just tr like what we've seen historically. It's very difficult to get user feedback. So it'd be great if the user said, I like this, thumbs up, thumbs down. Why didn't you like it? And then we could also incorporate that into the training. I just know in the past, even for just optimization models, it's been hard to get users to really engage and not just kind of click through it. So the big thing for us is in this weight room or Agent Dojo is a space where we're always watching them, watching what their results are, how they're reacting to queries over time. Do they answer the same queries in the same way? Are they using the same tools? Do we see a difference in frequency? Do we see that they're getting change in confidence? Is the orchestrator starting to act differently to similar queries so that we can monitor them and then decide if we need to do some kind of intervention. And also, as you get new agent versions, so you decide you want to train an agent and then you're going to retrain it, for a month till you get some more information on it, right? How does that agent compare to the previous version before you put it into play? And so that's how we're monitoring it and making sure that they're doing what we think they should be doing. I wouldn't necessarily advocate that we get rid of humans because we actually have an escalation loop. And even in our batch or trigger, where it's not a user chat, if it's a user chatting, it's easy to escalate, right? You can come back and say, I don't understand, I need more information, or I have these conflicting things, you're going to have to figure it out. But when you're getting an automatic request or a trigger, like let's say you get some data come in and it triggers a workflow, we also have an escalation channel for that, or like a queue that people can go to and see that. And so I wouldn't necessarily advocate for getting rid of people. I realize that maybe people see some savings there. I think it's more about making sure that the agents continue to give quality results and also to learn from it because you're going to get better at it. It's a very agile approach, actually, about what kinds of questions it answers well and trying to improve those and also starting to add in new contexts, new tools, new chains of thought as you progress with this, rolling it out to a company.
Great. As LLMs leapfrog each other, it seems like every month or maybe even every week or day, and other related kind of tools emerge. How do you, as a practitioner, view the different technologies and vendors and when you're building these kinds of applications and tools?
That's a great question. Yeah, it really seems like there's like the best model, and the next day there's another one. That's why we say hold technology lightly in this space, and we try to be very agnostic. We don't want to become a Anthropic shop or an OpenAI shop or a Gemini Google shop, just as we are honestly for a lot of technologies. Like we are typically kind of agnostic about our cloud software too. We can work with AWS or Azure or Google Cloud because we know that there are pros and cons, and our clients obviously have their preferences a lot of times that we work in. So we don't want to get chained to one of these models and then find out it's no longer the latest and greatest. I will say they're all getting so good, and honestly, like the Llama models are really good. What we call, small language models can be really good and will be getting better and better, obviously. And at some point, they're gonna all kind of be so great that the differences probably, and I mean, maybe already are honestly, won't matter so much. But I think part of it is just being modular in your thinking and your design and not building into someone's ecosystem so tightly that you can't swap out if you need to. And so thinking of that as a tool as well, right? The particular model technology that you're using should be plug and play as well, and building a framework that supports that because you're absolutely right that things are changing pretty rapidly. And I think that the leader in the models last year looks different than the leaders in the model this year. And there's some companies that we thought didn't do good models and now they do great models. And so a year from now, who knows what will be the leading model? It may be a company we've never even heard of have the leading model. And so, yeah, I think you have to hold it very lightly, be flexible, and be willing to swap out things when you need to or when you want to.
Got it. Thanks, Patricia. We'll just say there's room for another question. I'm looking at the Q&A. If we don't get one, let's see. Oh, okay, going once, twice, gone. Patricia, thank you so much. Again, we will, folks. This is recorded. We'll make that available. Um, we will be sending the presentation if you registered, so that we'll be emailing that out soon. You're always welcome to. You see Patricia's email address at the bottom of the screen if you want to discuss this with her, or just go to princetonoptimization.com and submit through our contact us and set up a call with Patricia if that's easier. But thank you, folks. Thank you for attending, and we'll look forward to seeing you again soon.
Awesome. Thank you guys. Appreciate it.